Our today's topic is waste to fuel in highway department, and I will briefly explain the waste asphalt challenge in Hong Kong, its environmental risks, and how we use a more sustainable way to trade it. Hong Kong's road network needs frequent resurfacing, which produces reclaimed asphalt pavement. The Highways Department reports about 1 million tons of asphalt and 200,000 tons removed each year, so substantial RAP stockpiles remain. But unmanaged RAP is not harmless. Research shows that aged asphalt can leach heavy metals and PAHs into soil and water, and that RAP stockpiles and pavements emit volatile organic compounds that add to air pollution in hot weather. So our project proposes a waste-to-fuel pathway that treats RAP as a secondary petroleum resource. Through pyrolysis, we convert the aged binder into liquid fuel and char, so we can cut waste, relieve landfill pressure, reduce greenhouse gas emissions, and create a higher value outlet for RAP.
So let's move on to the comparing between the conventional methods and their efficiency. So there are three conversion routes for asphalt waste. First is combustion. Commercially mature 20 to 25% electricity efficiency, no liquid fuel. The second is the non-catalytic pyrolysis, which is 90 to 95% low sulfur fuel oil from asphalt-rich feed. And the third is the catalytic pyrolysis, which is better diesel quality, but on mineral-rich REP, liquid yield only 7 to 9%, still at the plate stage. And the waste singles reach 95% fuel oil via the non-catalytic route, which is the highest conversion today. So the conclusion for the highway agencies, which is continue recycling the REP into the new pavement. For real waste-to-fuel, asphalt-rich waste like the singles, and they use non-catalytic pyrolysis, which is the only mature and the high-yield path to the liquid transportation fuel.
Hi, this is John. So I will be taking of the part 1 of the results and conclusion. So for the REP, so it is the most popular waste material for use on the highway in the US. Around approximately 45 million metric tons are milled each year. So you can see from the table below, 100% of the REP is recycled and is used for the different courses and pavement on the road. And obviously, it is going to be a very low cost due to the lower requirement of various material and landfill fee. In the other hand, in terms of durability and life cycle costs, REP is imperative for engineering as well. As you can see from the table below, the REP ran as top for both economics and engineering scores. Highway department sees REP as secondary resources and integrate up to 50% into asphalt mixture. On top of what I've mentioned from last pages regarding the cost, the expense can be reduced by 35%, and the greenhouse gases emission can also be reduced by 25 to 30%. And yet this advantage only applies on the surface cost due to the stiffness loss and cracking. And the problem concerned by far is the soil contamination by the heavy metal and leakage. And now I will hand it over to Joe for the part 2 of the discussions.
Thank you, John. To solve the problems caused by RAP, we can use pyrolysis as a solution. Pyrolysis can turn the waste asphalt into about 51% of diesel quality liquid fuel and remove the possibility of leaching of heavy metal. At 450 degrees Celsius, the pyrolysis yields up to 52% of liquid fuel with the residual coke. Therefore, the highway department can break even by selling 2 useful products. Besides breaking even, we can reduce the cost in pyrolysis by using a low-cost catalyst. The low-cost catalyst can produce about 51% of liquid fuel that is comparable to using expensive catalyst. In practice, the highway department is implementing several plans to carry out the pyrolysis in our city, such as the Waste Blueprint 2035. In practice, char is being tested for use as the activated carbon in water treatment. Besides, many researchers indicate that using RAP and recycled PET can reduce the expenses by 25 to 30%. In the future, pyrolysis enables zero waste towards 2035 landfill goals, and therefore more pyrolysis will be used in the future.
Hello everyone, I'm Zhang Xiaotian. Here is a summary of our Highways Department's research on waste-to-fuel conversion. To transform reclaimed asphalt into a valuable resource, we propose an innovative strategy, adopting new thermochemical conversion technology to efficiently break it down into clean diesel and high-value activated carbon, truly turning waste into fuel. The successful pilot at CSE Depot has confirmed its feasibility. To achieve the 2035 zero landfall goal, we recommend, firstly, scaling up pyrolysis with regional facility. Secondly, enhancing interdepartmental collaboration for better supply chains. Thirdly, promoting the use of byproducts in road construction. Finally, establishing a local database for accurate benefit assessment. Let's move beyond traditional recycling toward fuel recovery and position Hong Kong's roads as a model of circular low-carbon development.